going to prove some sum to product rules. First one's going to be the following. We want to prove that the sum of sine x plus sine y is nothing more than, let's see, it's 2 times, should be x plus y over 2 times cosine of x minus y over 2. So what we want to do is look at the following. We know that the sine of a plus b, this is equal to sine a cosine b plus sine b cosine of a. We also know that the sine of a take away b is sine a cosine b minus sine b cosine a. And in this case, we're going to add them. And we get the sine of a plus b times the sine of a minus b. And when we add, those two are going to cancel. And we get 2 times sine a cosine b. Now, this looks suspiciously similar to what we want to prove. The sine of one angle plus the sine of another angle. And it's supposed to equal 2 times the sine of an angle times the cosine of an angle. Just what we have. So I'm going to make a guess that if we let A equal this and B equal that, everything will come together. The beautiful part is I'm guaranteed to have the right side correct because I defined A and B accordingly. I'm letting A equal to x plus y over 2 and B is equal to x minus y over 2. All I have to do is write A plus B in terms of x and y and A minus B in terms of x and y. And hopefully A plus B will be x and A minus B will be y. So let's verify this. If you add the two fractions, well, they both have the same denominator. Now if you have positive y and you add negative y, that cancels out. But when you add the two x's, you get 2x over 2 or x. What that tells me is that for A plus B, I can put x, which I just did. And for A minus B, the two fractions still have the same denominator, but now we're going to subtract. X, take away x, that's gone, and positive y minus a negative y, why that's 2y. Ooh, we have it, there it is right there. Proof is done. Proof is done. Okay, now there's another proof, or another statement. That statement is very similar. The only difference is instead of x plus y, so let's call this number 2, instead of sine x plus y, it's going to be minus. And it's going to equal to, not cosines, sorry, not sines at the beginning, but it's going to be 2 cosine of the sum of x and y divided by 2 times the sine of x minus y over 2. Okay. So let us get rid of this. I'm going to keep the same definitions on the bottom. So I have a sneaky feeling that we're going to need them. when I subtract, the left side is going to be subtract these two equations. The left will be sine of A plus B minus the sine of A minus B. And on the right side, when we subtract, now this cancels out, and positive sine B cosine A minus negative sine B cosine A, or that gives us 2 sine B cosine A. Okay. So I have the 2, I have the sine, and for B, I'm going to use x minus y over 2. Now, not that that's wrong, but let me just reverse what I have over. This is going to equal to cosine A times sine B. Or will it? We will find out. Cosine of A is x plus y over 2, and sine of B is x minus y over 2, and the left side is going to be the sine of some angle minus the sine of another angle. But A plus B didn't change. It's still x. They didn't change because A and B are still defined the same way. And A minus B, that's y. And just from using a formula that we already knew, we got this new one, the one that I called number 2 up here. Let us look at the next one. The next one involves other functions. So what we want to show is that the cosine of x plus the cosine of y is 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. And we're going to play the same game. We're going to call that A, move this over, and we're going to call this B. Well, if A is x plus y over 2, and B is x minus y over 2, if we add A and B, the y's are going to cancel, and you're going to get 2x over 2, or x, and if you subtract, the x's are going to cancel, and the y's are going to add. You're going to get 2y over 2, or y. Okay? Well, actually, what I said is all true, but I goofed. We don't want to plug it in here. That's just going to change the letters around. What we want to do, I apologize, we want to look at cosine of A plus B plus the cosine of A minus B. And this, we found out earlier, is 2 cosine A cosine B. So now, here's my work. I wrote down this identity below that white line, and A plus B is x, so this will be cosine of x, plus A minus B is y, this is cosine of y, starting to look exactly like the left. Okay, now it equals 2 times cosine of A, but that's A. 2 times cosine of A times cosine of B, where that's B. And when we look, we're like, yeah, that's number 3. That's exactly what number 3 said. Okay. Now, number 4 is going to be very, very similar. It's going to be the difference. It's going to be cosine x minus cosine y. And this time it's 2 times the sine of x plus y over 2 times the sine of x minus y over 2. And we're going to use a similar identity to the one we just used last time. And the last time we looked at cosine of a plus b plus the cosine of a minus b. This time we're going to subtract them. And we're going to get negative 2 times the sine of a times the sine of b. And one thing I'm going to say is that I must have a typo here. There must be a minus sign there. Sorry about that. So this is an identity with that minus sign there. Okay. Cosine of a plus b. Going to use the same substitutions. A plus b is x. Okay. It is what it is. Cosine of a minus b. A minus b is y. And it equals to negative 2 times the sine of a. Well, a is x plus y over 2. The sine of x plus y over 2 times the sine of b, where b is x minus y over 2. And then I look at this and I say, yes, I have it. I verified number 4. And all I'm doing is using the sine of a plus b and the sine of a minus b. Sometimes I add, sometimes I subtract. For other problems, I've been using the cosine of a plus b plus or minus the cosine of a minus b. And it all comes together. It's like magic. Go over these. They are quite important.